अलिकति म रेकर्ड सुरु भयो
Bye.
सबै साथीहरूलाई धेरै धेरै धन्यवाद थ्याङ्क यू सो मच फर कमिङ आज डाक्टर रोमस ढुङ्गाना सरले चाहिँ प्रेजेन्टेसन गर्नुहुन्छ उहाँको चाहिँ अब हामी सबैले चिनेको उहाँलाई त्यही पनि उहाँ चाहिँ युनिभर्सिटी अफ कोलोराडो डेनभरमा चाहिँ फ्याकल्टी हुनुहुन्छ है त थ्याङ्क यू हुन्छ रमेशजी लेट्स स्टार्ट थ्याङ्क यू
Thank you, Rudraji. Okay, thank you everyone for joining the session, and I hope you'll participate in the clicker polling. And these are real questions, mostly from, let's see, kinematics, and quantum computing. So I have brought questions from them, example questions. Okay, so let's move on. So I'm gonna be muting some of you if there is disturbance from that side. Okay, you may not notice, but sometimes we can hear that. Okay, so I'll do that. Okay, but feel free to turn on microphone and stop me anytime. This is just like Rudra said, it is workshop style. Okay, there is no rush for finishing anything or anything like that. So feel free to stop me. Okay, and I'm guessing Rudra will be, Rudra Kafli will be monitoring the chat, and you will let me know.
Sure.
But anyway, so should we try this again? This one here, this question we tried. So let's see how many clickers are working right now. Let's try that. Okay.
Yeah, I already responded. Probably my.
Oh, I see. It's already running. I never closed it. Okay.
Right. Okay. Good.
Okay. So I see there are 4 responses, and during this I can open and see how the responses are if I like. But if I open this like this, then student can also see it. So that's why I don't show the result while poll is in progress. Otherwise, they have tendency of polling on whichever is getting most polls. So that happens. Okay. So because
can I ask you a quick question?
Sure.
So when you this response is looks like anonymous. So how do you track the students while you do grading? Thank you.
That's a very good point. So yes, it is anonymous. So that's a good thing about it. Okay, that's what I like it, because student can respond, or everyone can respond without like, let's say, feeling embarrassment of being wrong or something like that. Although there is nothing wrong with being wrong while we are learning, right? But sometimes we may feel like that. So, but this app tells me like how many students got correct response and how many of them participated. But it still does not tell me who got it wrong and who got it right. It simply tells me how many students got it right and how many students got wrong. And that's enough for keep track of, anything I like to do study about this. So that's enough for me. Okay. And so that's how it works. So now, once we are ready to close, what we can do is I can click on this red button. If you're looking at my screen, so it's going to close the poll. But what I do is I give 30 seconds warning to the students. So I'm going to say 30 more seconds. And then again, I start count down after 5, before 5 seconds, before I close it. So 5, 4, 3, 2, 1, and then I close it. So that way you didn't get enough warning to so that it's closing now. So that's what I do. And then what happens is, so although there is no right or wrong answer, but just for to show you how it works, what I'm going to do is I'm going to just choose one, let's say A as a correct answer. So now it's going to show up in the student displacement as well, or display as well. Okay. So now student has this question, and whether they get it right or wrong. So that response, and it is towards whole semester. So anytime they can go back to this question and review. Okay. So let's move on. So traditionally, the use of this kind of system, this iClicker or any classroom response system has been to check the conceptual knowledge like this kind of question, okay? And it works pretty well, okay? But if you are teaching large classroom and struggling is to engage student in problem solving, then we can also use this app or this device, this instrument to engage students. And doesn't matter whether the classroom is like 40 or 100, it almost works equally well, almost equally well, okay? I wouldn't say equally well, but almost equally well. So we can use that to engage students in, very large classroom as well, okay? So it encourages, or in sometimes it forces students to participate. Okay, so that's the beauty of it. So this is just an example of, let's say, traditional use of a classroom response system. So now I'm going to open the poll, and you don't have to worry about being right or wrong. Okay, it's just an example of participation. Okay, so don't worry about being wrong. Some of these questions might be, sometimes we can be wrong. Sometimes I can be wrong in this kind of question. Thirty more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay, so now we can see, let's see how did we do. So now what happened is there are varieties of answer, right? So when we have this kind of situation, what do I do is I ask class or students, if they are in Zoom like this. So let's suppose like many of you, I'm also thinking D as the correct answer. What do you think? Am I right or wrong? First, start with, am I right or wrong? And then tell me why. So by asking this kind of question, I'm not, like pointing out anyone who made the mistake. Okay, anyone can participate in that, discussion without any kind of embarrassment or anything like that, right? So in that case, one, sometimes two students, sometimes 3 or 4 students might join, okay, in this kind of discussion. So that's the beauty of it. So I don't have to tell why a particular question is right, but sometimes, yes, I may moderate that, but I don't have to. Sometimes students themselves come up with the reason behind why a particular choice is right or wrong. Okay, so that's how I use it. So usually the polls, depending on question, it goes from a minute to 4 or 5 minutes. Okay. And then discussion, sometimes it's quick within a minute. Sometimes it may take a little longer if more students participate, especially the one who first, participate and doesn't come up with the, good explanation or comes up with the sometimes wrong explanation. Okay. So in that case, another student might, chime in that case. So that's how it works. So what I'm going to do is, I'm not going to choose right or wrong answer here. This is just for experiment, okay? So I'm not going to do that. So I'll just keep moving, okay? I can do that too. So it is just an example, unless you want me to, okay? I do not want to choose correct answer here, okay?
Sir, can you please choose the correct answer? I'd like to know the answer for this
Okay,
question.
okay. Then Then I'll do that then. So looks
Can I answer what is the correct answer? Just kidding.
so okay, so yes, go ahead, Rudraji. Yes, I like that kind of
So
remarks.
yeah, so what is happening here is the on the vertical axis there is, I think, position, displacement, position plus x. In the horizontal axis there is time. So for the first few seconds the position is flat, means it is not moving, and then position is being less and less and less, going towards zero, right? So that means the object doesn't move at first, then it moves backwards, and then finally stops. That's what I thought. That's my explanation.
Yeah, that is that is correct answer, actually. So that means it's D is the correct answer, right? Move fast, then moves backward, and then finally stops. So yes, D is correct answer. So in this case, yes, the position, in terms of position, that's a great explanation. Another approach I use to describe is in terms of slope. For example, slope of position versus time graph is slope of position versus time graph is velocity, right? And so that way, if we think in terms of velocity, it's kind of easier to see what's going on. So for example, first a few seconds where the position is flat, that means slope is zero, means velocity is zero, means it's not moving. And then downhill looks like, right? But that is a negative slope, means velocity is now opposite, means backward, we can say, okay? And then again, the line becomes flat, means slope is zero, means it's not moving. So, uh, so yes, we can describe this in terms of either position or in terms of velocity. Yes. Okay. So now, so this one, another example of using concept, but this concept is very useful for solving projectile motion problem because we need to use that. Okay. So I brought a couple of conceptual questions, but after that I have also brought the problems. So that's the main reason behind that's the main goal for today's. So let's quickly pull on this one as well. Thirty more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay. Are you ready? Ready to see the result? Okay, let's see. So mostly C, and that is correct answer, right? So X component of velocity is never zero for the projectile motion because there is no acceleration in that direction unless it starts with zero velocity in the X direction. Then the velocity along the X direction never gonna, it's always same. It's a constant. That's what acceleration in the X direction, zero. So anyway, so here is another question where student struggles a lot. Okay.
Can I make a quick comment on the previous question?
Sure.
Yeah. So actually, this is a very, very challenging question. Probably many of us have experience. Like students think that when the object stops, its velocity and acceleration both zero. So it is very, very difficult to convince students that the answer is C. So if any of you would like to share how you have convinced the student that the velocity at the, the acceleration at the maximum height is 0, that would be fantastic. We can do that discussion toward the end of the session. I don't want to interrupt the presenters'
Yeah,
plan.
that's fine. And we can leave wherever, whenever
Yeah,
we
right.
want, right?
And another thing is,
Perfectly fine.
as Dr. Dungana mentioned in the beginning, like, so if you have questions, please feel free to unmute and share, because this class is basically, again, as Ramesh mentioned, like, we don't need to finish anything, like basically how we get the good feel of the tool which we can use in classroom. Thank you.
Yeah, Rudra sir. So do you want to discuss it now? I can share some ideas on the question.
Sure.
Yeah, that would be fantastic. Thank you. Thank you, sir.
So yeah, so what Ramesh sir is doing here, so he's using the iClickers, but I do the similar questions. I just give them the display cards in the class. So for this question, I have a little bit different version in my class. So what I ask them is, at which point is the velocity and the acceleration perpendicular to each other during this time of flight? So I have them draw that tangent at each point. So I give them maybe 4 or 5 points. So that's how they will know the direction of the velocity. And for the acceleration, it's only in the y direction and it's always directed downward. So that's why I have maybe 1 or 2 students come to the board, draw the vector directions. And that's how they know that acceleration is all the way, but the velocity is only in certain directions. And for y at highest point, that velocity direction is completely in the x direction. So there is no component in the y direction. So that's how I explain them why the acceleration is 0 at the highest point.
Probably. No, acceleration is not 0 at the highest point, right? Probably you.
I think I mean the velocity, not the acceleration.
right.
Acceleration is z all the time. So it's like, yeah, so acceleration is only in the y direction and it's always constant. So that's how it's the acceleration due to gravity whenever it is in the field, whenever it is moving free fall, either it is going up or down, it doesn't matter. So that's how I approach the problem.
Right. And thank you so much, Nawaz sir, for this.
Rudra sir, I would like to also
Yeah,
comment
please. Yeah, please.
Actually, University of Colorado Boulder has that simulation, FET simulation. And then in that FET simulation, we can have the components of velocity and acceleration as well. And then by distinguishing that simulation also, we can show that the velocity at the highest point, vertical component of velocity is 0, because there is a horizontal component of velocity, but the acceleration is non-zero through that FET simulation as well.
Nice.
I think it will be much more easier for high school students. Thank you.
Yeah, very good. So one thing, like, why is acceleration non-zero? Like, Navraj sir explained that, like, it is always constant, but how do we how do we get that feel to the student that it is constant? That's my
I think we can add that to this. So if we go to the definition of the acceleration, is the change in the velocity. So the velocity is still changing. When you are going up, there is a velocity. When you are at the top, your velocity is 0. And when you are again coming down, you have a number for the velocity. So velocity is always changing. That's why acceleration is not 0. I think that's what we have to stick with.
Thank you.
Navraj sir, here what I got the confusion or what I found from the student is that, well, when we say that velocity is 0, we mean to mention vertical component of velocity, or else horizontal component of velocity is constant there. So they might be confused there as well.
No, that is true. So when we do those vector diagrams, so that is clear which direction that is. So if you are completely parallel to the x direction, so they have to know that there is no y component of the velocity. That is true, but I do stick with the definition of the acceleration. If the velocity is changing, that is enough for the acceleration to exist.
Thank you so much.
I'd like to chime in a little bit. I connect acceleration with the gravitational force, since the gravitational force is always there, so the acceleration would always be there. So that's how I connect.
Yeah, basically.
Yeah, that's the definition of projectile stuff. Yeah,
basically
that force right here.
That basically what I think is what it is just said is like that is Newton's second law of motion, but unfortunately this comes earlier than Newton's law, F = ma, right? So yeah, anyway, thank you.
That's the beauty of this kind of questions. It it brings this kind of discussion even in the classroom, okay? Not everyone will participate, but some student participates in this kind of situation. So if you ask, how do I do it? So I draw the velocity in y direction and how they are slowing down, right? So I draw velocity arrows, and what happens is the first one gonna be longer than the second one, and so on when it's going up. So velocity arrow is becoming shorter and shorter. So that means velocity is decreasing, of course. Based on that, we can, draw that. And once we use any two of that to find the difference in velocity, subtract those two velocities, that's going to give you the direction pointing down no matter where you use, okay? And if you use more than two, then you will also get like tentatively same velocity. But to convince us then the value going to be 9.8, we have to do experiment. From here, we cannot do that. But direction, we can always show why direction is always downward by just subtracting two vectors, finding the difference vector from velocity 1 and velocity 2, two consecutive velocities. Okay, so that's what I do. I do the drawing. Actually, I use this, like drawing difference. I start doing that even before this. Whenever I start talking about acceleration, I introduce acceleration as change in velocity over time. Many students have this difficulty. They may write velocity over time, but that is not the acceleration. It's the change in velocity over time. That's the acceleration. So to establish that idea in their mind, I start from the very beginning of class. Whenever I start displacement, I start drawing those things and drawing the difference vector. So that's how I do it. So by the time we are here, I can simply draw and show them, see, it's pointing down. Okay. So that's how I handle anyway. So here is another question. So for students, I give a little longer time, but here I'll just do 1 minute and 30 seconds, okay, for this question. Thirty more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see, how did we do here? So mostly D. And there is 1. Okay. Okay. So let's say, I guess this one also makes some little discussion, I guess. Should we do discussion or just move on? What do you think?
I do have one question. So how do you display the correct answer? It is already set in the system, or do we have to click and say the students that this is the correct
I
answer?
have to choose. I have to choose which one is
Okay.
the correct answer. Okay.
I have one question in the procedure part. So when you display the slide, does the poll automatically comes or you have to start the poll?
So there is this green button, if you notice in my screen, right? So
Yeah.
this is iClicker, some widget, right? So it sits on top of your, presentation. So I click on this blue arrow here, green arrow, the green arrow. And then what happens is it basically first time you do it, it's gonna, ask you, do you want to share this one to the student or not? And if you say yes, go ahead, share this question, then it's gonna show up in the student's device as well. Even if they don't see my screen, they can still participate, okay? By just looking at their device as long as they are there. And then I have to start the poll and I have to stop the poll, okay? So that's how it works. So after I stop the poll, I show them the result just like I did here. And then I would say, okay, let's say just like many of you, I think D is correct answer. Am I right or wrong? And by the way, some students sometimes, I'm just going with the flow right here. I'm saying whatever student saying is, let's say I'm also thinking right. Am I right or wrong? But sometimes you student think I'm also wrong. Actually, I don't know. So that's why I'm choosing that one as the answer. Okay. In a comment, sometimes you see Ramesh makes a lot of mistake himself. The question he brings in.
I mean, probably, I mean, this has positive. What is happening here? Like this graph is tricky. Like, see, I chose E, like, but that is it. So see what happens. The slope is positive, right?
Yeah.
Slope is, but the velocity is negative.
Yeah.
All the time, velocity is negative. Shouldn't it be moving to the left?
Yeah. So correct answer is E. So yes.
Yeah, that's what I thought. Like so. Yeah, I don't know. I don't know.
Right. So for example, right now, what I said is, let's say like most of you, I think E is correct answer. Am I right or wrong? And why? That is to simply start the discussion, right? That does not mean I'm saying that is the correct answer, right? But some students think, okay, Ramesh also think that is the correct answer. He also thought that was the correct answer, okay? So yes, E is correct answer in this case because just like Rudraji explained, the velocity is always negative. So since we are assuming positive to be the right, that means velocity negative means this object is moving to the left all the time. But acceleration is positive because slope is positive. Slope of that graph is positive. So yes, it's kind of this kind of concept question. It's difficult to convince students sometimes.
Yeah, I have one comment. I have never used this tool before, but it seems like it will be a best way to figure out the confusion questions, basically, where most of the students will get wrong. Dungana sir, do you have any that sort of experience, that sort of situation where you found majority of the students got wrong on something and you worked on that part?
It happens, yes. It happens many times because I bring challenging question to the class and I tell each student, like, I bring challenging questions, so I don't expect everyone to answer it correctly. So it is for learning. We learn by making mistake. That's how I present these kind of question to the class, okay? But sometimes some student may say, another comment sometimes I see is, most of the student got the wrong and Ramesh is still just, ignored them and moved on. But I never do that. I, ask the student to come up with the answer and then later I explain it. Sometimes some student even misses that. So one or two comments that may happen, okay? And some do not like to participate, right? Some students, they just want to sit behind in the class and then somehow, get done with it. And so
Yeah,
also,
actually,
yes.
Actually, to add to that, like some students probably they feel, even if these are, since last 2 years, I have started doing, I always do poll everywhere, which is another software of this kind. And previously, I used to use the learning management system, import their names, but I feel that they are kind of they probably feel embarrassed, and so that's why I started doing anonymous. Still, some students are hesitant to participate in this. how do I motivate them to participate? I always tell them, you don't, I mean, unless you log in, you will not be recognized by the system. It generates random ID. Please vote, because we are learning. Even if you make a mistake, that, I mean, we learn that way. But still, I cannot convince. I see that like 40 students sitting in the class, and there are 35 responses or 30 responses.
This is the way to do it. So in my class, unless some student is not coming regularly in the class, they don't participate. Otherwise, most students use clicker and at least choose the answer because they get credit. And it's very easy for teacher to give credit because it keeps the records of everything. Okay, so it shows you, I give credit based on just participation, not for being right. Okay, so that helps student too. So let's say I brought 100 questions during the semester, and if student participated if one student polled on 80 of them, that means it's 80%. So if I have up to 5 points, then they get 4% credit for that, for being 80% time, for polling 80% of time. So that's the, these days, sometimes it happens. Okay, I don't know if they are saying jokingly or they are serious, but when I ask them to participate in demonstration in class, okay, who's gonna volunteer here and come and hold this wheel and I'll spin something like that? When I ask for participation, they then ask me, am I getting extra credit for that? Very difficult to motivate students to, make them participate. Yeah.
So, Mr. I can share something. So I used to, as a TA, I used to use the iClicker at Boston College. So we had the similar problem there. Only 80% or 85% of the students will participate. Then I worked as a TA for this astronomy class where this teacher, he didn't use the iClicker. So he used just the ABCD display cards. That's what I use in my class currently. So after that, I learned that, so when you are anonymous, so students will know that teacher is not going to know who does not participate. So I think that is one of the reasons why some of the students will not participate. So in my class this time, I'm taking the record of how many students answered wrong, right, and things like that. So I found the non-participating are only 1 or 2 students out of the 45 or 50 students. Because what I have them do is display the card. I let them know if you participate, that is enough. So I'm not going to grade you. I assign the 5% grade, and I let them know that I'm not going to grade you depending upon either your response is correct or wrong, but depending upon how active you are, depending upon your learning curve, depending upon how what is your motivation you showed in the class. So the non-participation is not much of the issue for now for me. So that's why I hesitated to go from those manual cards to the these class-based assessment systems. So that is one of the things I noticed. So and what I do is once they display the answer first time, I go and look around the class and I create some joking, I tell some jokes or maybe they laugh, and even if they are wrong, they don't feel they are wrong. So that's what I'm doing. And I then involve them in the discussion and I have them display the cards the second time too. So that has solved my problem. Now the non-participation is only 1 or 2 or 3 students in the class.
Yeah, that's good to know. Yes, traditionally that's been before iClicker, that's how they used to do. Actually, when first time I learned about these multiple choice questions and these kind of display, when I was, when I joined for the postgraduate diploma in education PGDE, run by the Central Department of Trivandrum University Education Department. That's where I learned. At that time, they used to bring that kind of, ABCD card and fold, you can fold and sew, right? So they used to distribute to us, and that's how I started. That's how I learned about this multiple choice question and then participation. Otherwise, I had no clue, okay? Now, this is just using tech. And if you are teaching like me, if you are teaching 300 students in a semester, keeping track of that kind of thing is a little bit difficult or time consuming. This app makes it very easy. It keeps track of everything whenever time, like after past midterm, I put together these participation score and post that on Canvas. I have to do it manually, but just once, right? And I do that at the final as well, after the final. Okay, so it makes it easier. But yes, you are right. Okay, only thing on the modern, days, like student may still feel a little bit shy about displaying the answer because they may still think, like shy about being wrong, because at least although other students may not see it, okay, when they are displaying something like that, that's how they are encouraged to do it, to be anonymous. But student can still see it, right? I mean, the instructor can still see it. So that's why these days, fully anonymous. We want to keep this fully anonymous. But yes, that has been the the traditional way of doing this all the time. That's how it started. Okay,
Great.
thank you. Okay, so now now we are actually entering to the main topics of today, and looks like we are almost like in our time limit. But I will at least show you one question. How do I break down these questions into different components? Right? So so that way, you will have some idea, how it can be done, just in case. So if you are still wondering. So one thing I found very interesting about the idea is that we usually, I especially, I don't know what other people do it. I usually did not, like let's say, give them big picture of the physics 1 class, right? So when I'm teaching physics 1 class or introductory physics class, basically these are main 3 things we teach, and other are basically 3 or 4. I have put that in 4 categories. Other things are mainly application of these ideas. Okay, so these are the 4 main ideas. One, just we start by defining things, right? Definition or vocabulary. So that's one kind of thing we learn in physics. And I tell each student, okay, just like when you are first starting to learn to read, you have to have some vocabulary, right? Without having any vocabulary of any language, you cannot learn that language. Same thing goes with the physics. So you have to have some sort of vocabulary first. And the second one is like, after that, I enter into these are kinematics we focus on. And there are 3 equations of kinematics. And it's all about everything, no matter what problem you are doing, it's about using those 3 equations, either in one direction or 2 direction, mostly, right? And solving that equation. After that is algebra, okay? So think in terms of that. So that's how I tell them. It's about just learning how to use these 3 equations to solve any given problem related to kinematics, okay? And then after that comes laws of motion or dynamics, okay? One main equation. To use that equation, you have to learn certain steps. And after that, you should be able to solve any problem related to that using that same setup. And another going to be conservation principles. And there are 2 conservation principles. One is conservation of energy and conservation of momentum. We focus in this class, right? So that's how I present them. So this is big picture. That's what we are learning. And when I go to the class today, we start by definition and we are doing kinematics. Once we move to the, like let's say laws of motion, hey folks, see, we already learned about kinematics. So now we are focusing in dynamics. Isn't that great? We have already finished one main thing about, what we're going to be learning in physics, and we are focusing on second one. And we are only, there is only one left, and so on. So I keep saying this thing again and again, almost every class. Okay. And there is one example of, for example, oh, I forgot to remove this animation here. So I bring this kind of question after I define displacement, right? And then ask question right there. What's the displacement, right? So should we poll or should I just display the question? What do you think?
So probably we'll go ahead because we have spent a good amount of time in the previous discussions. Like now we have a good feel like how it works. So probably we'll move ahead. Like that's what I That's what I think. Thank you.
Yes, yeah, that's what I thought too. So that's why I asked, okay? And I bring question right there, right? And then these are the kind of response we see, okay? I can see this, okay? And so that question, so most of the students, chose B, and then there were some A and C as well, but who chose which, I cannot see it, okay? So that's the beauty of that. So I'm showing you this screenshot, okay? And here is another question where they needs to go from displacement to velocity. And it also tells them that velocity is directly related to displacement, and not just, not just the position, okay? And why that is important. And I also use this idea why displacement and distance, they are not same, why they are different, and so on, right? And this is the kind of, see, there are a lot of students making mistake there. You can see there were a lot of students choosing D as well, okay? So they still don't write initial position, final position, and do the subtraction. Rather, they just try to eyeball it and then make mistake. And that's good lesson, Don't use your just intuition, use the equation you have learned in physics to justify any answer, okay? Otherwise, you may be wrong. And so, yes, this is another, question regarding the just the definition, but this one is a little bit more difficult, but directly related to that. So this is another way to use this clicker question to solve problem, right? This kind of definition problem where you have just one equation, is then uses that, but it may not be that obvious, still could be tricky, okay? So this kind of question. So here they have to first, figure out what's the initial velocity, what's the final velocity with correct sign, okay? So to do that, what I'm doing is I'm actually giving them choice. So it's a practice for them to how it's done. So in first step, they do not just want to start plugging numbers, rather they need to first list what is initial velocity, what is final velocity, because the definition of acceleration contains change in velocity, which is final velocity minus initial velocity. So to give that idea, I bring this kind of question rather than, yeah, I could have just listed the answer right away. I did not. So that's the breaking a problem into different steps, many steps, okay? So this is the idea I'm using. And then later I have the display of the answer as well. Not at once. So traditionally, some clicker user, they use this as well. So they bring just this question, this question like this, okay, just the answers, right? But I am bringing this with the intermediate steps, okay? So now they are involving in the process of solving problem rather than just choosing one answer just for participation. Yeah, they may still do that, but now it encourages them to actually go through the process of solving the problem, okay?
Actually, can I add a quick comment on this?
Sure.
Actually, there is a kind of big words of what they call critical thinking. Probably this process also develops their critical
Yes,
thinking
of
skill.
course. Every problem solving involves that. And yes, thank you for pointing that out. Yes. And then another one, for example, now I'm moving to the dynamics. And dynamics, oh, by the way, this is not dynamics yet. By the way, this is still example of vocabulary, work done. How do you calculate work done? By different forces, right? So there are no intermediate step, but you can see I have the definition, the way I use it, right? And then what force means, what's displacement. And then I also have note at the bottom, remember, right? So work is a scalar. It means any negative work is less than zero work, less than zero, or any positive work, those kind of things. Some students still think, okay, negative 10 is bigger than zero, okay? So I like to remind, especially vector, negative sign means direction, value means value, but for the scalars, it's different. So kind of helps me, to introduce that. But of course, I bring this once I start work and energy chapter, but here in this presentation, I'm grouping them. These as an example of definition. Okay, just directly using one equation to solve problem. Work is just that we are using definition of work, okay? So now this is example of solving kinematics problem. So this problem, I have written the answer of this in detail, as you can see here. So this very first kinematic problem we do after we introduce kinematic equation, very first kinematic problem we do in class, okay? So, and of course, sorry about the small font. I'm just grabbing the, screen of my PDF note. So I have broken this down into steps, okay, different steps. I ask the student to go through these steps to not to make mistake. So once you go through this, you should be able to solve any kinematics problem like this in one dimension, okay? So that's the reason behind, bringing something like this. And don't worry, I have example, for example, of, let's say, using kinematic equation. See how I have set up this question here. The equations are right there. You see that? Question is there. Equations are right there on the side so that they don't have to hunt for the equation somewhere else. Another thing is, I want them to be consistent with the notation so that you keep using that notation and can also use that notation to solve problem in the, during the exam. So if they randomly write notation, they may get confused and so on. So I keep that, there. And again, there is a note over there. Please don't forget to sketch the situation before listing knowns and unknowns, right? So once they sketch, that's gonna help them to basically, figure out what they need to do and so on.
Can I add a note to this?
Yes.
So it is very interesting that there were a few students in my class. Actually, they were very, they did great in the exams, but they asked me like, I'm following Young and Friedman's textbook, like originally Sears and Zimansky, and it has like a standard notation, but they did something else in high school, other notations. Like for example, if we recall back in Nepal, we do U for initial velocity, V for final velocity, like that. And some of the students came to me and asked, Professor Kafle, can I use my notation during the exam? Like, so this is actually very interesting, what Ramesh ji brought here. So keeping consistency in notation, like removes a kind of confusion in them. That's great. Yeah, thank you.
Right. So in the exam, actually, I don't look at their work. I give multiple choice question even in the exam, okay? So I don't mind whatever notation they use, but I want them to learn to do it properly. So if they don't write in terms of components, once we enter to the two-dimensional motion, then that's going to be a problem, right? And so on. So I encourage them to write everything in terms of components. That becomes, easier even for the dynamics, okay? So, process of solving any kinematic equation is to first list known and unknown. They have to know it, right? And if they write in terms of the notation we have in the formula, that way they can, easily choose which formula to use, or sometimes you may have to use more than one formula, right? So anyway, so that's why I first start something like that rather than just, giving the and looking for the answer. And then after that, I say, okay, which equation then, right? So that's the second step for solving any kinematics problem. One equation, or you need more than one, right? So that's a next step on solving kinematics problem. So that's how I go about it, okay? And of course, before I move to the two-dimension, the components becomes really important. So although in this example there is force, but it is also true for velocity, acceleration, and so on. So I bring this kind of question right there in the class, okay? And I ask them to actually draw the right triangle and figure out the components right there, okay? So that's how we can involve them. And by the way, some of these questions, for example, this question, I have made slight modification. If you are wondering, do I have to make this question myself? In physics board, I think you can download some of these iClicker questions. Since I've been teaching for a while now, I have modified these questions for my liking, my need, but there are these questions with the answers available there. You can you have to create your instructor account, and they will verify you are indeed the instructor, not the student. Okay. So after that, you can have access to the physics board, and I'm pretty sure most of you do. From there, if you search for this kind of material, you can find that. Okay.
Yeah, I just posted the link of his board in the chat box in case. Yeah, thank you.
Right. Okay. So, and then after we do this exercise, I tell each student to do this and show me your work. Okay. So these are possible component situations they encounter, throughout the semester. If they can master it, they don't have to struggle drawing component when we are focusing on solving, let's say, projectile problem or dynamics problem. Okay. So for projectile motion, these are main thing I focus first before we start doing the projectile problem, because the thing that in the box, right? Constant acceleration downward in the vertical direction, and acceleration in zero direction. First, I have to convince them, but after that, this is the things that you can use to solve any projectile problem. And I say there are mainly two kinds of projectile problem: one thrown horizontally, another one at a particular angle. So basically these two, and no matter what kind of problem it is, so that's how the initial velocities and final velocities in a particular direction works. I show them, okay? And after that, what we do is we start solving actually problem. Same process, okay? Same process. List the knowns and unknowns in terms of components, right? And then find the knowns and unknowns, and then actually write those variables in terms of correct sign by choosing axis. Without choosing axis, you cannot just start sticking numbers. So sometimes I like to choose down as a positive to remind them we can choose, we don't have to always choose up as a positive. Okay. So that's how I do it. So the process is similar, right? So it is just a 2-dimension, but slide is, there are going to be more slides for this 2-dimension. Okay. So you can see, I'm keeping those things that we determined from the previous slide. I'm bringing them here, right? And then moving on to the new thing, okay? And of course, this is same question. So to remind them, hey, this is same question. You don't have to keep reading the question, but full question. But the new thing is on this colored one. So focus on that one for this part of the question, okay? So I separate with colors, right? And the same question is also in my note, okay? So it's done in detail. So I don't spend time solving, doing algebra. I only do physics in the class. I don't do algebra and arithmetic in class. So I have note for some of these questions. They are done in details, right? And others, I tell them, you practice, you do the algebra. I have made video to how to do algebra for those who needs help. Otherwise, they can do it. So this is another type of question I have shown. So now, since we already out of time, I like to show you just one question from dynamics. And after that, I can stop, okay? Okay, so I emphasize 3 main skills to solve any dynamics problem: drawing free body diagram, and then choosing the suitable coordinate, because we like to write Newton's law in the X and Y direction. It's not just always one dimension problem, right? So I emphasize that, and I write Newton's law like this in terms of component rather than just, yes, I write once, and then after that, I break this into components, and I tell them this is how we're going to be using it, okay? And then to draw a free body diagram, I have listed these different kind of forces, how they act, when they have to draw, what they have to keep in mind. Whenever they have to draw a normal force, how to draw, right? And so on. And then free body diagram, I test just separately for free body diagram. And after that, we move to solving actual problem. For example, in this case, the dog is sliding on the slide and it's accelerating down, right? So I'm asking the student to calculate the acceleration, right? So now, I do not want to go to the detail. Oh, yes. Details, what I did, but I like to emphasize what are the things and why I do it. So you can make this kind of question. So directly gives you the answer at the end without breaking this into a step. So this is one way of doing it. Traditionally, that's how it's been used. But what I'm doing is breaking this into components. Again, same problem. Now, rather than displaying this slide first, this is going to be my last slide, among the several slides I go through. So do I have to do this for every problem? Yes, would be better, but at least for one problem for kinematics, one for, projectiles, one for the dynamics, Newton's laws of motion, at least. I go through this, different. So now another thing is, another interesting thing, probably you may have also heard, I often hear, I know physics, Ramesh, or Dr. Ramesh, Professor Ramesh, sometimes simply Ramesh, right? I know physics, but when I read question, problem, I get stuck how to start, okay? That's what they tell me often, okay? That's what I hear. They tell me, they also write me email simply saying simply that. Yeah, I'm not doing well because I'm not doing great in the class because I get stuck once I start solving problem. Although I know physics, that's what they say, okay? Okay, so now that's why I'm focusing this kind of thing. So now kinematics done, now we have dynamics. So we have now several equations. So which equation to use? That's what these then try to first, hunt for an equation that gives them answer, right? But what's the process of getting equation? It's not just like eeny, meeny, miny, mo, and choose one equation and use it, right? So is this kinematics problem or dynamics problem? How to identify that? So here are the reasoning, right? So in kinematics problem, although there is acceleration involved, but acceleration is related to initial velocity, final velocity, displacement, and so on. But in dynamics problem, there is acceleration, but there are now forces involved, right? So that tells, us what approach to use. Is it kinematics problem or dynamics problem? So that one first I like to make them clear, bringing this kind of question. Okay. And then after we identify it is a dynamics problem, then first requirement, draw a free body diagram after knowing what's known, okay? Draw a free body diagram. So to draw a free body diagram, they have to know which forces to draw. So I am giving this exercise of identifying what forces are involved in this case, okay? So that's what I'm doing. And then after that, I am drawing free body diagram, possible free body diagram, right? I'm giving them choices. So which one? So now, since we identified, okay, there is friction, there is, weight, normal force, and so on. So how do we draw it correctly? Okay, so that's another step. And after that, so to choose a particular, coordinate, it's always easier to choose in the direction of acceleration. So that's why I ask them to identify direction of acceleration if it is accelerating, or if there is motion, even if it's not accelerating, identify the direction of motion. That way you can draw one axis in that direction. And then after they put the axis on the free body diagram, then another task is they may have to find component of the force that's not pointing in a that chosen axis. So that's next step. So that's what I'm asking. Okay, you drew. So now can you tell you need to draw find the components, and do you know how to find components? First of all, they have to identify which force, right? And after they do it, now I'm showing them components, possible components. So they have to actually draw to figure out, okay, which component go is the, correct for, in this case, weight, right? And after components done, then comes the part where they can use the equation, right? Finally, it's time to use equation. So now I'm asking them to, hey, go ahead, write the equation in a particular axis and so on, and giving them choice. So they have to first write to correctly identify the choice, right? And I also have detailed solution of that question, this particular question I bring to the class as a note. So my job is done. Once we write the equation, done. Next is solving equation, which is algebra, I tell them. And plugging in number, if numbers are known, it's arithmetic, right? So you should be able to do it. If you cannot, I have note, I have done that in detail, go look, but you won't get that note for each and every problem. So you have to get used to it, okay? So that's what I tell them. So anyway, so this is dynamics. So I had some slide, prepared for the questions like, let's say, quantum computing as well, but I will just show it. And yeah, this is for entanglement exercise. And these slides, I did not make it for the quantum computing. I got from the physics board, by the way, okay? I'm not that good at quantum computing yet to make my own slide. Good slides. Yeah, I can make slides, but not good slide. But introductory physics, I think I can do good job. Okay. So anyway, so that's that. Okay. So sorry it took
No,
longer.
oh yeah, thank you. Thank you so much, Wesley, for very nice interactive presentation. Like this should be helpful to new faculty members or even graduate students and postdocs, like who want to go to like teaching or colleges or schools. So yeah, so if there are any questions, like probably we'll do informal discussion now, and so probably we'll stop recording and we'll do informal discussions if we have any questions for a few minutes. Thank you.
Okay, so I'm gonna stop recording then.